I've been going over how to integrate with parts. So integration by parts relies on this formula. It goes as such. The integral of u dv will give you uv minus the integral of v du. What does this mean? Um, I think it's better if I show you in an example. All right. So when you have a problem that involves integration by parts, you want to figure out what your u and dv is. That's the first step. We want to figure out what this is, right? Um, the pro this is essential because the problem is predicated on this. Ideally, you want when you pick u and we take the derivative of it, which is du, you want it to um, give you a number, so you don't have to integrate by parts again. You want to avoid a number and a variable. Um, this way, if you just have if your du is just a number, you can just simply integrate this regularly without by parts, and you can solve the problem. If it's not if it's a variable and number, you're gonna have to do integrate by parts again, and that will be a separate process, which I will show you later in the video. So let's start with this example, right? Step one: figure out what's our u or dv. So we have an x and we have sine x. Which one of these, if we give a du, is going to give us a number in our du? If we do sine x, it's going to give us cosine x, and that's going to be a problem. But if we do x, the derivative of x is what? 1. So that's what we're going to use for our u. For our dv, we're going to use sine x. So for u, in order to get the du, we have to take derivative of it. But for dv, in order to get the v, we have to take the integral of it. So remember that, right? It's basically what I just said. We'll pick x as our u right here, and we'll pick sine x as our dv. And for dv, we have to integrate it, and for u, we have the derivative. So if we take the derivative of u, if we take the derivative of x, we get 1 dx, that's our du. If we take the integral, there should be a dx over here, I apologize. If we take the integral of dv or sine x, we get negative cosine x for our v. So now we have our u, our du, our dv, and our v. So go back to the formula. U, we have that. Forget this, sorry. We have our u, we have our v, we have our v, and we have du. Now let's plug it in. So if we plug in our variables, we're going to get x as our u. Our v is our cosine. I just brought the negative cosine to the front, so it's negative x cosine x, just to make it easier. So our u is our x, our v is negative cosine x, minus our v, which is our negative cosine x, and what's our du? 1. Simple. So we insert the variables that we just obtained from the last slide into the formula. Now what? We want to make a little bit of make adjustments so we can simplify the problem for integrating. So this is what we had before, right? We had negative cosine x over here. What could we do to make it more simpler? We just bring the negative out front of the integral, and when you have a negative times a negative, we get a positive. So we rewrite the equation as negative x cosine x plus the integral cosine x. And what do we do? Integrate. We'll integrate this, and we'll get what? Positive sine x plus c. So the answer is negative x cosine x plus sine x plus c. If we didn't have a number and we had a variable, we would have to integrate by parts again. All right. let's look at the next example. The integral ln of x. That is going to be hard to do it by regular integration, so we'll do integration by parts. So we have to pick our u, our dv. What's our u? What's our dv? We're going to imagine that there's a 1 here. I mean, there's a 1 there, yeah. And we're going to make our u ln of x, and we're going to make our dv 1. So if we make our u equal to ln of x, this will make our du 1 over x, because that's the derivative of ln of x. And if we have a 1 as our dv, if we integrate it, that's going to make us have a v of make v equal x. So what do we do from now? We insert the variables we just obtained from the last slide into the formula, and we get this. Our u equals ln of x, our v is equals x, minus the integral of our v is x, and our du is 1 over x. Next step, what is it? Simplify it. Let's make some adjustments. So what can we do to make this more simpler? Easy. We have x over x. With x times 1 over x, these x will cancel each other out and we're left with 1. Now what are we going to do? Integrate. So if we integrate 1, we get x. So this is going to make the answer x times the natural log of x minus x plus c as our answer. Now for the final problem, this one we are going to have to integrate by parts twice. Alright, so we have x squared over ex. How do I know which is my u? How do I know which is my dv? So if I make ex my u, and then my du is going to be ex again. And that's not really going to make me get rid of it. But if I make x squared my u, I'll get my du as 2x. And the next time I integrate parts again, I can make 2x my u again, and I'll get 2 as my du, which would be ideal. What did I just say? I know it sounds kind of confusing, but just follow with me slowly and I'll explain it, right? So first things first, we want to figure out what's our u and dv. I'm going to pick x squared as my u, and I'm going to pick dv as my, I'll pick ex as my, e to the x power as my dv. Alright, once again, I'm repeating it. I picked u as x squared. I picked dv as e to the x power. If I take the derivative of x squared, I get du, and my du is 2x. If I take the integral of du, if I take the integral of dv, I get e to the x, which is my v. So now I got my u, I got my du, I got my dv, I got my v. I got all the components that I needed, right? Now what we're going to do, we're going to plug it back into the formula. My u, x squared, my v, e to the x power, minus the integral of my v, e to the x, and my du, 2 to the x. So what's the problem over here? If we can't simply integrate this because we're still left with ex and 2x. Like, so we need to integrate by parts again. If it was just one number, we could have, but we can't. So we have to integrate by parts again. So what I like to do is, when I'm going to integrate by parts again, I ignore everything but the stuff I'm going to integrate by parts. So this, I'm just going to leave off to the side and deal with in the end. So my main focus is going to be this. What's the integral of e to the x, 2x dx? So we pick our u and our v, right? I remember I said I'm going to pick u to be 2x because my du is going to equal 2, which I know will stop me from being able to integrate by parts again. And my dv is going to be e to the x dx. So when I integrate this, I get v to the e to the x. So that's the thing you have to have when you're dealing with integration by parts problems. The idea is to make your du as simple as possible, so you don't have to integrate by parts again. See, that's why I picked 2x, because my du became 2, and I don't have to deal with integration again. I can just take the 2 and put it outside the integral. All right, what did I do? I inserted the back to the equation. So look, my u is 2x, my v is e to the x, minus my v e to the x, that's a type with an x, times my du, which is 2 dx. I want to make it simpler. I take this 2 and I pull it outside of the integral, and I make it negative 2 over here. And in the integral, I'm just left with e to the x. I integrate e to the x, and now I have 2x times e to the x minus 2 times e to the x. That is the integration by parts for that section. Now to finish the problem, what we're going to do is we're going to insert the problem and insert what we just found out back into the part that we ignored. So remember in the beginning I told you ignore this and just leave it out. We have the results for this already, right? We have this now. Now we're just going to insert it back and associate it with this. So we'll put in parentheses. This is what we found out. 2x times e to the x minus 2ex. We're going to carry the negative 1 because we distribute it to both sides. This will make the parentheses negative 2x to the ex plus 2ex plus c, and that would be the solution of the problem.